Okay, I have a tiny amount of time today, so I'm going to do a short little stream to see if I can finish up where I left off last time. Um, Basically, I am going to attempt to load in some data segment dumps from DOSBox X from inside the summoning. Um, this is a little bit tricky because I have a couple of different moving parts. I built a hex editor inside Jupyter a while back, and I'm going to try to use that. And who's to know if that's actually going to install or not? So we'll see. But I'm going to get started now. And all right, let's first test to see if I can get this running appropriately. Let's move my Jupyter Lab over. So this is my Kaitai. Let's see. Nope, that didn't work. Let's see if this works. Nope, didn't work. So I'm probably going to give up on that for now. Oh. Yeah, I really need to update this whole thing. Let me see if there's a quick fix for this. Jupyter Lab Extension. Develop dot overwrite. Let's see if that'll fix it, and then we'll give it one shot. But while that's going, I'm going to load it up inside DOSBox X. So this is a snap package of DOSBox X. I've got it all on inside Snap, and it's built with the debugging symbols enabled. So I'm going to use the DOSBox debugger here. Let's see if rebuilding it fixes it. So that requires using the terminal. We're going to go over here to the summoning. What I'm going to do is I'm going to, I forget if debug is a command. No, it's not. Okay, so we will run debugger, yeah. So what I'm going to do here is first I'm going to do a video debug overlay. Now this is fun. So what we'll be able to see, and let me see if this executes while it's going. Let's see if I've got the hex mime type working. Okay, so we do have the hex viewer. That's nice. I'll be able to load that up now. I ported this from Kaitai Struct, and so it's from the Kaitai IDE. So you can give credit to them for that, but it works inside Jupyter Lab. That'll make things a fair bit easier in just a few minutes. So I'm going to run summoning. Now I need to explain about the what we are seeing here, and I actually was never able to get the aspect ratio to scale. So let's see if I can scale this right. See, it's set to scalar 2x, but yeah, let's see if I can now fit to aspect ratio. Reset window size. There we go. All right, so this is a little bit bigger. Now, the neat thing about all of this here is we have our palettes down here. Now, I'm going to play the opening to the summoning. Oh, and it shifted it over to this screen, and I don't know why. Now, check this out. I'm going to start the DOSBox debugger. Now, look at the palette here. This is super cool. So the way that they're drawing the lines across the screen, and let me go back here and we'll do run, is they're doing a whole bunch of animation just using the palette. So it's going to fade out with the palette, fade in the text with the palette, fade out with the palette, but when they fill in the text in just a moment for the summoning, you'll see the palette shifting with time. Yep, so it fades up just by modifying this section of the palette, and it fades down the same way. So it's got the full VGA palette here, but it's just modifying that in order to get the animations. I love this. And then in a moment, we're going to see the summoning, and you'll see it fill up with like redness, and it does that whole thing just in this section, right? See, it's cycling it. cycling this. And so that is how it updates the display. All right, now it's going to pull up the copy protection. Let me see if I can, let's see, video, reset window size. There we go. Okay, now I got to get the menu, so page 35. Okay, so this guy with the hood, feathers, and horseman. Okay, now what I want to do is I'm going to start a fresh game, and ideally I'm going to get a data dump. Let me go back here to, there we go. So we've got the debug window. I'm just going to use Johansson. We'll select him. I'm going to start the game, no opening. Once we get started, we're going to do a couple different memory dumps. Up here, the data segment is set to 8557. So I'm going to pause inside the debugger, and then I'm going to change a couple different aspects. So we've got our memory here. We're going to memdump bin. We're going to start at the data segment, which got reset to 2BEB. I think that's the switch between the two executables in summoning, code 1 and code 2. 2BEB. We're going to dump out FFFF. Wait, do I have the syntax right? Let me check again. Memdump bin segment colon offset and then the length. Okay. So memdump bin segment 2BEB offset 0000 length FFFF. So now, right now, we've got this memdump bin. It's 0xFFFF in length. So we'll grab that one. I'm going to make a new directory for this. Let's see. We'll call this 2024-12-22 game 1 bin. Okay. Now let's go back here. We will restart it. Okay. And now we'll debug it again. We will do the exact same thing that we did. Memdump bin 2BEB 0000. Okay, so now what I've done is I've moved slightly. And let me take some notes in this too. Just started out, default direction. Changed direction, moved slightly. Okay, now we're going to do one more thing. We're going to unpause, and we are going to execute a move. Oh, check that out. See the palette's changing? That's how it does some of the animation, not all of it. We are going to change. Oh, hey, check that out. Split LNCMP. Yeah. So this is, it does partial redraws based on where the split LNCMP is. So it allows it to target two different areas in the memory. So now we've got agility 10. Let's put something in our hands. And now this is 3 apple in hand. All right, so that should be enough for now. to get us started. So I'm going to move this off screen. I'm not going to reload this. So we've got our examples here. Okay, I'm going to what's the difference between these? Okay, well, whatever. It's probably going to end up not working anyway. It just seems to be how things go lately. I'm going to quit this Jupyter lab and restart it in a different directory. Well, that's not great. Okay, I'm sure that'll not come back to bite me. Let's go here into core dumps. Let's create a new file. All right, now let's load in our array. So this will be our first one. Open the first one, RB, read. Call this game 1. And the same thing for game 3. All right, and then we are going to diff these 3 different things. So let's take a look at the first one. Okay, so this is the entire content of our data segment. Okay, now if I select something here, we'll see it parse into that. Over here, it'll show the different values. So let's find out where things are the same and where they are not. Import numpy as np, np.from buffer game1, ng1, ng2. Oh, and I'll give it a d type of u1. So what we want to do is figure out how different these things are. Now, there's a whole bunch of different state that gets updated as we go through this. This should all be U1. I don't need to change all of those. Okay. And let's just verify. Yep, all true. Okay. So now let's see how different they are. How much changed in between these different time steps, just as I've been modifying them with minor differences. So ng1 equals ng2. Remember, the difference here is that I changed direction. Whoa. 454 elements are different out of that many. So let's see ng3. So much changed between ng3 and ng2. That's suspicious, actually. Makes me wonder if I did something wrong with the buffer dump. But let's take a look at ng1 and ng2, where they are different. So np where ng1 not equal to ng2. Okay, so it starts out, and we've got a sequence of them right here. So we've got a big, long run of them. Looks like every couple. So these are probably 4-byte values that changed. So let's go ahead and take a look at that. So hex viewer, ng1, Oops. So game 1, I'll say this is HV1, HV2, hex viewer of game 2. And now what we'll do is down here, and I will create new view for output, create new view for output. Okay. Now, can I rename this? Nope, cannot. Okay. So now what I'm going to do is I'm going to say HV1 dot traits. So I've set up a bunch of different traits on this. Selection start. No, that's not what I want. Buffer, tabbable. Did I add a scroll? Looks like I didn't. Dang it. Oh, I thought I did. Maybe there's a way to do that. Give me just a sec. No, looks like I've just got selection start and selection end. Okay, well, maybe that'll scroll when I do it. So right now the selection start is there. We'll highlight from 1077 to 1163. 430. Yeah, that sounds about right. Okay, so it looks like I don't have a mirroring quite right. Okay, so there's the first one. Now down here, let's move to 430. Column 5. So this is our first set of differences. Let's display what they look like. So NG1, 1070, let's say 0x430 through 0x440. NG2, 0x430 through 0x440. '53, 49, 63, 57. All right, those are all the same. And then here it changes, 43, 32. And all of a sudden, things start changing. So this, here, 32 and 23. This is the first set of differences that we might see. Let's take a look at what we think is going on in those areas. And we'll do that by pulling up Ghidra, looking inside our data segment inside code 2. Taking a look at 430. Now our code segment here is 3226. That looks like 430 is a pointer. 4C3. That's not great. Yeah. All right. Well, that's not the right approach. So let's see if we can figure out the next item. 6180. $1824. Now let's take a look down here. A lot of FFs changed to 0 zeros. Okay. So now let's go back here. Now with the dynamically allocated memory, sometimes this stuff gets a little bit wonky. So let's see. Let's see if this comes up with anything. I'm starting to think that I've got the wrong understanding of the way this works. So the way that we could identify connections between the data segment inside Ghidra. That's interesting. Yeah, that's a bunch of function pointers. That's not what we're looking for. So instead, let's see if we can figure out how we might be able to identify our character's location in memory. So let's go back here. And run. You see he's got strength 15, agility 10, 11, endurance 12, AC 15, talent 10, power 12. So let's see if we can find a string of characters, or a string of numbers that matches that. Now I have, inside Ghidra, figured out the character information and the way that it gets stored. So character position, nope, that's not it. Inside here, we tend to have max agility, max endurance, max accuracy, talent. Oh, it's accuracy, not AC. All those in a row. So, and then current agility, strength, and so on. Each one of these is an int 8, because they only take on values between 0 and 255. So, what we can do is we can make a NumPy array, character stats is equal to np.array 15, and we'll do current, which is 11 for agility, 12, 15, 10, 12. Okay. We'll say, actually, we'll call this cur stats. And then we'll do max, because max here, agility is 10. So cur stats to buffer, 2 bytes, yeah. Let's see. There we go, 20834. Now if we look at max stats, you'll see it's right afterwards. So let's go to this area, 6D82. 6C8, 6D8. There we go. $15, there's our strength. 11, that's our current agility. 12, current endurance. 15, current accuracy. 10, current talent. PW, power, current power. So now in principle, we should be able to modify this. Now, I'm kind of curious if we can, and what it'll do to the game. So let's do it, just to make sure. So we'll data view to BEB, which is our data segment. Oh yeah, data segment and E segment. And then what did we say our hex here was? 6D82. Okay. Oh yeah, I think I've gotten very confused about how to do segmented memory appropriately. Okay, DV. So let's just go to, if I press Alt-D, it dumps me into the data segment. It doesn't it? DSSI. Yeah, okay, I want DSDX. So that's Alt-X. So that's data view virtual. I actually want segmented data view. How do I set the segmented data view? Yeah, that didn't do it either. All right, I guess what I'll do here is let's compute what the segmented address is. I always get mixed up on this because I don't think it's just as easy as 0x2BEB plus 28034. I don't think that's it. Ugh. But I guess it's worth finding out. 9960, DV 9960. Okay. Yeah, that's not it. I actually thought that was, it looks like maybe that is. All right, here we go. Here's a code golf example. And what do we say this was? 6D832. 32C32. All right, let's see if that doesn't. If not, I'm just going to go back to it. No, that just gives me spells. All right, whatever. But we know where our character's current strength is and so on, and so in principle, we should then be able to figure out the offset from that into our pointer. To figure out the differences between them. Okay. Oh, and just like that, my time is up. Okay, I will have another go at this another time. Thanks, folks, for joining me.